But what are we going to talk about today? We're going to talk about Nuke, as Ricardo said. It's a very, very cool build automation platform. It's an open source. It's written in C#, and let's go on with it. So, as Ricardo said, I'm a .NET developer, a DevOps evangelist, not a DevOps engineer because there's no such thing. I'm a clean code fanatic. I really like everything being green. The compile needs to be green. The builds need to be green. No warnings, nothing. I am kind of obsessed of that. I'm a speaker for the past couple of years, father of 3 boys, and I love karaoke. If you want, we can do some karaoke afterwards. It will be fun. So let's not postpone anything else and just ask ourselves, how do we do builds today? I mean, how do you define build definitions? How do you create them? How do you support them and whatnot? And you know, in the different build systems today, we usually use YAML, right? Because we want to have infrastructure as code, because we want our build definition to be part of the repository. And I'm sure many of you have already met those nice screens that you're seeing here for GitHub, GitLab, for Azure pipelines, or whatever, what have you. And all of them sooner or later migrated to YAML builds. Some of them, like Azure, had other different steps, but they are constantly migrating. And YAML is the king here. So YAML is widely adopted by everybody. Everybody wants to use it. So the question would be, what's the problem then? Why not using YAML? Well, I will tell you why not. Let's take a very quick look at my repository in GitHub. So this, by the way, is my awesome app repository on GitHub. You can go check it out. It was created especially for that presentation, and it contains an awesome application which doesn't do much, but its idea is to showcase Nuke and how you can use it and how you can create a build definition with it. So in this awesome app, I have a continuous workflow for GitHub Actions, which was defined in a YAML file, and I'm showing that to you at the moment. And I'm sure that many of you already noticed that there's a problem with that YAML definition, or you haven't. Well, if you haven't, there it is. This is the big problem with our YAML definition. And I'm absolutely sure that this is a negligible little thing, and many people would not see it, and you will just do what? You will commit it, and you will start your build, and you will be right, okay, I'm going to have coffee. When you come back, boom, your build is broken. Why is it broken? Because YAML is broken. And why YAML is broken? Because of a single space. If we go back, you can see that this width that is highlighted with red is just one space further than the other ones. And this is the problem that I have with YAML, that it's supposed to be this easy to read and understand markup syntax by people, but yet it is so easy to mess it up. And because of things like that, I say with my full power, dear YAML, I hate you. I really do. I hate you from the bottom of my heart. I can go on with XML. I can go on even with JSON, but YAML, it's a little bit too much for me. And the thing that you can very easily screw it up is not the only problem that it has. Since being just a declarative markup thing, all of the different providers, they have their own schema, which is kind of normal because some people call it, some platforms call it tasks, others call it stages, steps, whatever. And if you want to have build definition in one platform, you got to learn its schema. If you want to move to another one, or you have multiple projects in different platforms, you have to know all of those. So it's a learning curve that brings another layer of complexity to this whole process. And because of that, again, dear YAML, I so much hate you. Please stop existing. So, so if we go back and think about, then do we really have a problem? Turns out we have a lot of problems with using YAML definitions. We cannot debug it because it's just a simple file. At least I haven't seen any way of debugging YAML in your build. Customization is a little bit tough. Whatever tasks your CI system is providing you, that's it. This is what you're limited to. Highlighting and IDE support is also kind of there, kind of going there, but it's nothing compared to compiled languages. It's nothing compared to having a C# code, for example. So all of that brings us to what? Of course, Nuke. So Nuke, as I said a couple of times already, is a cross-platform automation system, built automation system. And I'm not going to try to define it. I'm just going to shamelessly steal it from their website, which, as you see, is a cross-platform build automation solution for .NET with C# DSL. So it doesn't have YAML or Java or JavaScript or XML or other strange type of configuration or like Terraform or whatever, some made up thing that you have to define things. It's C#. It's a language that developers already know. And the approach is to embrace the existing IDE tooling. We already have very powerful IDEs. We don't need to invent new ones to solve a problem which is already being solved. And the third one, and I cannot stress this enough, is that a state where everybody in the team is able to manage and change that, because this is DevOps, right? We want the team to be able to easily do that. And if it's YAML, you usually end up with the DevOps guy in the team, or you end up with a DevOps department or whatever, because they know YAML, they know things. I'm just a developer, I write C# code. Well, guess what? You can have that and still do your build definition. So how did Nuke come up? Well, thanks to this handsome fella. He's called Matthias, and he's the creator and main supporter and contributor of Nuke. He's an awesome developer, a very, very, very good one. I admire him really much because of all the passion that he has put into that project and the way he's developing and doing for it. So what I have to do with that? I helped. I'm part of the contributors. I contributed to that project. Of course, not so much. I have one commit, but it's something. I mean, I've been there. There is some code there running, which is mine. I wrote it. So yay, I'm a contributor now. So that is it. Nuke, the best thing that really happens to me in the past years. But now I'm sure that I've spoken so much things about it and telling you that Nuke is this and Nuke is that, and you're starting to wonder, okay, how exactly does it work? I mean, is it a service? Is it something that you deploy? Is it in the cloud? What is it? What is it? What is Nuke? So it's really easy. It's kind of genius. It's just a project. It's just a console application, which is part of your solution. So it's build definition code that sits next to your production code and test code. So it's not something that is decoupled from it, it's the same thing. So but not only that, not only being just a console application, Nuke in itself is so much more. We have a global tool for those who are not familiar with the .NET ecosystem. A global tool is a CLI application which is distributed using NuGet packages. So it has a global tool that can help you set up and do stuff with it. It has extensive libraries that were already written with tons of useful classes already at your disposal. And CLI tool support, this is really cool. I'll show you about it in a minute. The fluent syntax, again, perfect thing for developers, love it. At least I love it. CI system integration. This one is the gem in the crown, but we'll get to that later. It has some very wonky path handling, which is really cool. Solutions and system and projects models. You can do notifications to Slack, to Teams, to Twitter. It has ID extensions, which you don't need out of the box, but they help for some things. You can do build sharing and so more and so much more. So without further ado, let's dive into some of those features and show you some of that stuff. So how do you set up Nuke? So imagine you have a repository and you have all your code inside with all your tests, and now you want to create a build definition for that. So you just go in your repository. First of all, you need to install the global tool that Nuke provides, and this happens really easy. You should already have .NET CLI installed. If you just call this command .NET tool install, it will install the Nuke global tool. And from this point on, you can use it as if it is part of your system already, because it puts it inside the path global, in the path variable. And then you just call Nuke setup in the root folder of your repository, and it starts this console wizard, if you will, asking you a couple of questions in order to fit things to your needs. It asks you if you want to name the build project differently than _build, or use the default one, in which folder it should be located, which version of the library you would like to use. And it identifies, it finds your solution inside. Is that your solution? Yes, it's my solution, of course. Do you need help getting started with a basic build? This is a really cool one because it just puts up a class with some already predefined build inside, so you can, it gets you a head start. Which CLI are you using for restoring, compiling, and packing? .NET, MSBuild if you run .NET framework, older legacy applications. Where are your files located, source files? Where are your outputs? Where are your tests? Do you use Git version? Git version is another very cool thing, which I'm not going to go into detail, but if you want, I advise you to check it out. It's a really cool CLI tool that helps you do semantic versioning based on your Git history. And all of that, and you're ready. You're ready to start using Nuke. You're ready to start exploring the cool things that it does. So, but now you might be asking yourself, okay, so now what? How do I define the build which is created? Well, I'll tell you why. How? Why? There are the notion of targets. So as I mentioned earlier, different systems use different stuff. For example, GitHub calls them stages or steps. I don't remember. Azure DevOps calls them tasks, things like that. Here they are called targets. Basically, those are the steps in your build definition. So if you take a look at the build model tree of a build definition, so you have a clean step, right, where you just clean some old stuff from previous builds you had. Then you go to restore some packages from npm, like npm install, NuGet restore. So we won't compile the code. Then you run some unit testing, some integration testing, and then you pack your stuff. You pack NuGet packages. You pack even whatever JavaScript stuff out there. I'm not very familiar with it. So, and you publish those packages, and then you announce in Teams for your team to see. Of course, there are other branches where you don't want to compile because it's a Docker built image which compiles itself, and so on and so forth. So the build tree gets something like that. Of course, it gets more complicated with time, with the growth of the project. So how those things are presented in Nuke? They are presented as properties inside a build class. So you have a build class, which is basically the main class for your console application, the initial one, the startup one, and you create those targets inside. So in this example here, we see that we have a clean, a restore, and compile target. So we just define some execution stuff for each target, which is the body of the target. So what does it do? Because I can do whatever I want here. I can reference whatever libraries I have access to in C#, and I can do whatever I want there. So then you can see those before statement and the depends on. These are the things that are helping you build the dependencies between your targets. So for example, if I run the clean and restore target together, I'm ensuring that the clean target is going to be run before the restore target. And if I call the compile target, since it depends on restore, it will automatically first run the restore target for me and then run the compile target. So all of those things are part of the platform, of the framework built that Nuke is, and are considered when you do the execution, when you start running that. And now when you're seeing those dot before, dot execute things, if you're not familiar with that, this is the so-called Fluent API or Fluent interface. So if you don't know what a Fluent interface is, it's a thing that was defined by Eric Evans and Martin Fowler quite some years ago. They came up with it. So it's a way of chaining methods for defining an object in an object-oriented language. And if you don't know who Eric Evans or Martin Fowler are, then I strongly suggest you go and find out, because they kind of matter. So this is a very, very cool approach to programming, at least in my opinion. And it really makes your code kind of human readable when you go through it. It flows, it's fluent, as the name suggests. So if we're looking at this thing here, it's a task that I'm calling .NET test, with setting the configuration to configuration, setting the build to no build, to not build the assemblies before that if the compile target was among the succeeded targets. Reset verbosity, set result directory. We have a conditional here. You see that is server build. There are many constructs like that Nuke gives you out of the box. Like is server build is a already provided a property for you, which can give you true or false based on that if the build currently is running on an agent in any of the build systems or it's running locally on your computer. Yeah, this is another cool thing. You cannot run YAML build definitions on your computer, but you can run Nuke because it's just a CLI tool. You can combine it. This makes a combinatorial logic, so it can parallelize your tests. It's really powerful. And this is how a Fluent task conversion would happen. So if I call the .NET restore and I fluently add the set projects file solution, when I run Nuke in the log file, I will see, because Nuke logs out each CLI call to your different tools that you're using to build up and create your application. It will show me that I'm calling the .NET executable with the command restore and a parameter for the absolute path to my solution. This is how it will translate to. And this is really, really cool, and not many systems show you that. And by talking about CLI tools, let's talk about CLI tools. So I've showed you a couple of those, which are also called tasks inside Nuke. So let's not forget. So targets are the big ones that are your step builds, and tasks are CLI calls or methods that you would utilize as part of your Nuke libraries in order to populate and do stuff in your targets. So that's what tasks are. So the CLI tools, Nuke already gives you quite some possibilities and already prepared stuff. So it has already generated libraries for all of those tools that you're currently seeing on your screen. It generates them. It's called generation based on metadata. So that metadata for all of those tools contain all of their comments and parameters and help, and it automatically is generating C# code for that and put into the Nuke libraries. So, and that's the real cool thing about that, is that when you're writing your code in your IDE and you're getting the help for each method or property, you're getting the actual help that you can see on the command line reference, either on the site, or if I run Docker help, it will show me the same thing as you're seeing here for Docker build, which is really awesome and makes you easy. Because, for example, I might know how Docker CLI works. I might know the syntax of Docker, and then I would very easily build the task here in Nuke for it, because I already have the same structure, the same notation. And working with other executables is also a breeze, because the ones that I just showed you, they are really cool, but they are kind of limited because, yeah, we can't do all. And if you want to use some third-party other executables, because I might have some executable that my team has written, and it does some very special thing to our project when it's building it, copying some files, encrypting some stuff, I don't know, whatever. You can very easily do that here. If I just declare a Docker property and I put the path executable attribute, Nuke will automatically search for a Docker executable file inside my path system environment variable and link it to that property. So when I call docker.invoke or call, I can easily do that. I can easily go on and execute it. So you can also locate it via absolute or relative path. So I know that I have a special tool somewhere in that folder. Please link that to it. Or I can do it from a NuGet package, which is another very cool way of distributing CLI tools. And how do you do that? This is a very simple call with a task. I can, if I don't have already prepared this fluent syntax building of the command line ready for me, I can just build it with some string interpolation. I can just say, okay, I want to call Docker, and this is the things that I want to pass, and this will run Docker run italpine sh, and that's it. It just works. So the next thing, and this is the bomb, the CI systems integration. So let's just take a little step back. Let's go back to the place we were talking in the beginning, that different systems, they have different schemas, right? So how do I, now maybe you're asking yourself, okay, I still need to call Nuke inside GitHub Actions or Azure pipelines. I still need to make that pipeline initiated. I still make that pipeline run my Nuke definition. How do I do that? I have to still go and create the YAML file. Well, not really. Nuke gives you that also. So it has integrations with 4 of the biggest CI systems out there. More are coming, of course, I'm sure, but it works with, as I showed here, TeamCity, GitHub Actions, Azure Pipelines, and Upware. So if I put this attribute on top of my build class for GitHub Action, and I give it some settings, which are all refactorable and referenceable values. Because, for example, the way I'm creating this array of invoked targets here using the name of test and name of push packages, any IDE that I use, if I want to rename the test target, it will intelligently refactor it and rename it here also, not doing a string replace, because if I want to rename something in a YAML file or a JSON file, it doesn't really work, right? You have to apply some linguistics logics on it. And if I put that on my build and pour magic, I have a generated YAML file for NuGet for GitHub Actions. And this is exactly the YAML file that I'm using for my GitHub action in the awesome application repository. I have no idea how the YAML schema for GitHub Actions looks like. I don't know what you need to do. I don't want to go and learn it. I don't care about it. I care about C# code. And I've put that there and it just did it for me and I'm not thinking of it. And this is instructing GitHub Actions how to run my Nuke build, how to extract artifacts, how to parallelize tests on different machines, and so on and so forth. It's awesome. And just to give you a quick look, I will show you a demo. So this is my repository, the awesome app repository. And if we go, you can see that here in the workflows, this is my YAML definition. Again, I have no idea what this thing is. I know how I've created the build attribute. And when I go to actions and I go to some of my builds, I can see that I've given it to run on 3 different machines, 3 different operating systems. They all passed. And if I select, let me go back here, I can download my packages. I can download my test results. And this here doesn't integrate this well. But if you do it in Azure pipelines, for which unfortunately I don't have at the moment a demo to show you, but there is a separate tab just for test results, and Nuke tells it, here are your test results, and they are visualized there with graphics, with failed tests, with everything out of the box without me doing anything. And if I go and check out the steps, what that continuous YAML file did, the most important one, of course, is the one that is running the build CMD file, the one that Nuke generated. And I can see here this Nuke logo, and I see all the output for all of the different targets that I have. And it's collapsible because Nuke instructed GitHub Actions that those things need to be put in a region. And you can expand them. You can see this beautiful summary at the end. Each target, how much time it took, how many tests do I have, how many of them passed. It's just beautiful, and it just works. So the next thing, viewing your build tree. So as I said, it's quite normal that your build definition grows a lot, at least mine do. And if you take a look at the Nuke repository, because Nuke is building itself with Nuke, if you take a look at their build definition, it is enormous. But at some point you start asking yourself, okay, I don't really remember this target. Where does it go to what does it depend? What does it do? Well, of course, Nuke got you covered here also. If you call the Nuke global tool with -- plan inside your root repository, or even if you call your definition, because the global tool is doing exactly that, it's calling your build definition, the one that you have created, to visualize a plan, it will come up with an HTML generated build tree where you can see all of the dependencies between your targets. And here, mine are just a few because the build definition of awesome app is not so complicated. But if you have a big one, this could help you a lot in visualizing the paths and branches and workflows of your build definition, which sometimes can be interesting, right? The next thing that I really enjoy about Nuke is the division operator magic. So as I mentioned, there is some path handling magic that they are doing here. And because builds tend to need paths, they need path to your project, you need path to your dependencies, you need a path to whatever. So working with folders, directories, and files can get a little bit tricky. So they have built those really cool classes called absolute paths, because the suggestion for Nuke is that you always use absolute paths if possible. And for example, here you can see that I'm defining a property source directory, which is of type absolute path, and it's pointing to a root directory, which is one of those already given to you goodies that Nuke supply for you, which is just an absolute path to your repository's root directory. And this division operator is being overwritten to work as a combined operator. So root directory and SRC, this is doing the same as path combine might be doing. It will end up with an absolute directory to your source directory. And even better, since it's cross-platform, it doesn't matter on which system you're doing it, it will do the appropriate / or /. So you can see that those root directory, test directory look the one way in Windows and totally different way in Linux. And they just work, and it's awesome. And the last thing I want to point out here is the IDE extension support. So as I said, out of the box, you don't really need it because this is C# code. Your IDE already supports everything that you might need. But of course, there are some little things that can help you out with your Nuke definition, and this is what the extensions do. So in order to show you that, I'm going to show it in a demo. So this is Rider here, and this is my awesome app, and this is my build definition. So as you can see here, I have all of the things that I've already showed you, and these are my targets. And because I have installed the Nuke extension, you can see this little icon next to each of my targets, which is what the extension is giving you. So for example, since it's a C# code, I can put a breakpoint here. And I can, okay, there is something funky going on with my clean target and I want to fix it, but I don't know what. You know what I can do? I can run it. It works, but I want to be sure. So I'm going to debug it. And it will stop here. And you can debug your build definition. You can expand and see variables. You can swap things. You can see why this little thing there is not copying the other little thing there, what it's supposed to be copying it. YAML that. So what I want to really ask you at the end of that is to be part of that community. As every other community, the Nuke community is growing and it needs support. Together we can create a great platform for that. And there are already many contributors. There are sponsors. I'm one of the sponsors because I really like the project and I support it in any way that I can. So I advise you to go check it out. If you would like to participate, you can always open issues, you can do pull requests, you can contribute to the project. And if you are willing to enable to, you might become a sponsor. If your company is using it and they see benefit in it, you might want them to sponsor it. Because just a disclaimer, I'm not getting a dime of all of that, but I really believe that great software needs to be open source and it needs to be supported like that. And we need to help it grow and push it forward so it can do better for me and for you as developers and DevOps specialists, not engineers. With that, I want to say thank you for being here. It was an awesome presentation for me. I enjoyed it a lot and thank you for inviting me. These are the places where you can find me and I'm open for questions.